Okay, welcome everybody. This is Flat Earth Civil Discourse episode 22 with our scheduled guest is Sleeping Warrior. He has not shown up yet, but I did get an email from him less than an hour ago saying that he was just getting a bite to eat and then he's going to be in. So I sent him the link. I just checked my email and I don't have anything from him. So I'm just going to sort of set the stage for this, and we'll see. We'll give him a couple minutes, and if he doesn't show up, then I'm just going to start my presentation, and maybe I'll turn that into a more clean video. But this is live, so thank you for all the people in the comments, and I just want to, or in the chat, and I just want to say that once Sleeping Warrior gets here. I do not intend on paying any attention to the chat because and the thing is, and I hope you guys appreciate this, when I'm in conversation with somebody and that person is talking and I'm dividing my attention with I'm kind of half listening to what they're saying, but I'm really reading what's in chat. That's not, I really try not to do that. I occasionally, I something pops out in chat, but multitasking is a myth. So, I do appreciate these comments. But I just want you guys to understand that in my 1 hour conversation, my focus is going to be on what I would like to say to him and what I'm hearing him say to me. My focus is not going to be on responding to chat messages. So to answer the question, what's the best cheesesteak in Philly? So you guys have heard about Pat's Steaks, Gino Steaks, and then on South Street there's Jim Steaks. I would not set foot in any of those establishments. Believe me, I have, and it's very disappointing. So here's a question for you. Would you rather get and Sleeping Warrior is here. Hello, sir.
Hello, sir. How are you?
I'm doing just fine. Just let me finish my thought with Tim Reedy. He asked about the best cheesesteak in Philly. Would you rather have, Tim, a freshly made cheesesteak or one that comes from a factory? Because if you get it from Jim's or Pat's or Gino's, it comes from a factory. I mean, it looks like a factory. But if you go to any street corner on Philadelphia, literally any street corner in Philadelphia, and say, can I have a cheesesteak? That's where the best cheesesteak is. All right, Sleeping Warrior. Do you mind if I call you Anthony? I'm sure we've been on a first name basis. Anthony, thank you so much for joining me here. I really appreciate it. So
apologies, I let you down yesterday, Charles. I got waylaid with time, and I just had to take an opportunity. So apologies. I didn't mean to let you down. I knew that you were there, but I had to take another offer, I'm afraid.
Okay. I'll try to up my I'll try to up the ante next time, right?
I mean, Nathan charges 15,000 for a debate with you guys. I only charge 12. The invoice is in the post. So you've got 28 days to pay. It's fine. We're friends.
Okay, there you go. And I do appreciate you being here. So just to tell the audience, so when I asked Anthony to to come on for a conversation, the way we have these conversations is typically it's just a conversation. It's me talking with a guy, and we may disagree about the shape of the Earth. But Anthony suggested that we focus in on a topic, not that it would be a formal debate. And then so he said, suggest 3 topics. I suggested 3 topics. He picked one. So what we're planning on doing is spending an hour talking about using observations of the sun to determine the shape of the Earth. But it is a conversation. So it's like, this is not a formal debate. Anthony, I hope you will feel free to give and take. And so I've got stuff to present. I hope you've got some arguments. And so, let's jump in.
But give me a minute while I work out. I need to log into my bookmarks, but just give me a sec while I work out why I can't get into my bookmarks.
Okay.
Is it because? Oh, it's because it's on the wrong Google account. Do you want to make a start with your... I was going to say make a start with yours, but let me just log out of this. But hang on, this might kick me out. If this kicks me out, I'll come straight back in, okay?
Okay. So, so I'd rather not start if you're busy working on behind the scenes. So I'm just going to talk to the audience a little bit.
Yeah,
And
that's
then
good.
once you're ready, then we'll start. And I want to say, thanks to everybody in the chat. And I just want to remind you guys that the normal tone in the flat Earth debate among Globers and flat Earth folks has been, lots of animosity, lots of insults. I know people tend to be very, very thin-skinned, on both sides. There are some people who are on both sides who are in it for sport. I do not respect, I don't respect that. I mean, it's, I'm not trying to judge people. It's just that I want my channel to be a place where, it's hopefully mostly free of insults. Okay. I can get a little snarky. All right. I think everyone's got that in them, but so if the folks in chat, I just, if you guys could, just try to, just bite your tongue. Like, let's say somebody is attacking you. Just bite your tongue, laugh it off, right? Turn it into a joke when someone, oh my goodness. That's a hoax, Stringer News. That is a hoax. Look it up. But just laugh it off. If someone insults you, laugh it off. And then, but try not to have the insults. If you're debating with somebody in the chat, just try to, or even if you want to respond to something I'm saying or something Anthony's saying, let's try to keep it a clean chat. And a bunch of people have wrenches. I hope the moderators with the wrenches are going to be we used a very light touch. I think the comments that are automatically hidden is anything with like a couple trigger words, like the classic insult trigger words in the flat Earth globe Earth debate. If you use one of those trigger words, your comment will get hidden because it sounds like you're probably just doing an insult. Don't call people an idiot. Don't call people retard or flat tard or globe tard, and because then your comment will get hidden. Just let's have a nice time of it. I hope I hope to have a good conversation with Anthony, and I hope everybody gets something out of it. He's been in this for years, so I will probably not convince him, and I've been in it for years, so he'll probably not convince me. But the idea is to have a civil exchange of ideas, and then hopefully everybody will be better. Will be better for it. So yeah, I do appreciate everything. And so again, while we're just kind of chit chatting along before we get started, if you do know a flat earther who would like a conversation, because the thing is, I try to specialize in just very casual, very low intensity conversations. So if you are a flat earther, if you know of a flat earther, please feel free to email me, and then we'll set something up.
Okay.
And, Barry on is amenable to bribes. So Anthony, how things look like on your side?
They're good. Let me just say, like, obviously we'd had a conversation before on email, and I'd said, like, just pick your best three. Suggest your best three topics, and let's see if we can pick one from there. And obviously you'd said that you wanted to talk about, and I'll quote what you said so that we can forearm the audience so that we can see exactly what we're talking about. Your words were, where is it gone? Oh, right. So this is now not grouping my stuff together. Okay, that's all changed. Right. What was you said? It was something like, I'm paraphrasing because I can't find it immediately. It was something like, there we go. Using careful considerations of the sun to determine the shape of the earth. That's what we're talking about today. Careful considerations.
Or careful observations. I don't think I use considerations.
Yeah, sorry. Careful observations of the sun to determine the shape of the earth.
Yes.
Excellent. So that's what we're going to talk about today. So do you want to lead and I'll follow, or do you want me to lead?
Yeah. So I've got some slides prepared, and so basically, let me just show you my okay. So I'm oops, didn't mean to show that. Let me do this is what I'm not going to talk about. I'm going to call this low hanging fruit. This is not what I'm going to talk about, which is sunrise, sunset at any latitude, any season. The sunrise basically reveals that the Earth is not flat. So that's an easy. I just wanted to throw that in there almost as a joke. But this is actually the crux of my presentation. So I've got 3 main points and 3 main areas of exploration. Is the sun local? Are we standing on a sloping surface? And then are we standing on a rotating body? So Anthony, why don't I take a couple minutes and go through just point number 1, is the sun local? What's in yellow? And we can have a conversation about it. And then maybe if you want to touch on a point, but basically these are my 3 main points. Does that sound good?
Sure.
Okay. And then we're not going to play any rules with like timing or whatever. If you feel you need to jump in, please do so. This is not a formal debate. So with the first area of exploration, is the sun local? One of the things that is important is that it is, we can call it canonical. It's canonical that the Earth is on the flat Earth, the sun is local. All right, and it doesn't matter any map, any model, even if there's no map or no model. If you consider the Earth to be flat, the sun is local. So that's really important. So we're going to first talk about the sun size. And there are countless flat Earth videos that show this progression. Now, this is at about 30-minute. It's a 30-minute time lapse, and the sun gets 10 times bigger. There is no flat Earth model where this happens. Even the most extreme size increase on a flat Earth map or model would be 3 times in 6 hours. So this is clearly not a careful observation. So I have a video. I've got tons of videos telling people how you can make careful observations. If you use a solar filter, you get the true size of the sun. And I did this myself. I recorded for 8 or 9 hours from or before solar noon to just before sunset, and I found that the sun did not change appreciably. And according to again, just the most common flat Earth map, which people don't agree with it, but according to the most common flat Earth map, the sun should have been 2 times bigger at solar noon. Now the second one for is the sun local is the sunrise sunset azimuth equinox. And again, begging the question is, you're going to start with a globe to prove the globe. Okay, so this is not a globe proof. But what I'm showing you is just an illustration. It's just an illustration. So on the date of the equinox, you've got a north-south terminator line so that literally everybody sees the sunrise due east. They'll see the sunrise due west. And if everybody on that line is seeing the sun in literally the same direction, whatever you want to call perpendiculars to north-south, right? We've got a north-south terminator line, then that means the sun has to be distant. All right, and then again, this is not necessarily the flat Earth map, but just pick some sort of flat surface, put a sun on it, and if you have the sunrise and the sunset due east and due west, in the green and the orange, those are all pointing to one sun. Now, some people say, it's a projection or it's a reflection, whatever, but it seems to be a little bit of gymnastics that would be required for the sunrise sunset azimuth angle. So my argument is that the sun is not local because the sun size remains constant, and we have a due east, due west azimuth. All right, that is my first point, Anthony.
Okay, so first off, we've got to really start off with what is the sun? Because this is one Nathan asks all the time, and you've been away for a while, so I wouldn't really expect you to understand why he asks this. But when you say the sun, and it can be viewed in the equinox due east for everybody at the same time, what actually is the sun? I know what the parable tells me. The parable tells me that the sun is a hydrogen helium plasmoid of blah, blah, blah. But that's a physicality. How can we verify scientifically or otherwise that the sun has got a physicality to it? Because when I look in the night sky, I see a whitey, yellowy spot on the sky, and it looks just for all the world like when you get a laser lamp and you laser it on the floor and the cat chases it. Well, that's kind of what we're doing in the sky. It looks like we're looking at a projected light of some kind in the sky. And how could we prove that Icarus was flying to something physical, something tangible, something actual? as opposed to just a light and proof of creation. I mean, I'm not even a biblical guy, but I realize that the sun and the moon are quite unique, and they both seem to defy physics. They seem to defy everything that we can perceive, and the only thing that we can use is spectrometry or some kind of sensor to perceive frequency lengths of the sunlight. And we then say, well, based on these frequency lengths, we can say, well, it must be hydrogen because it matches that one. But that can also be interpreted as a false positive. And it can also be, well, it looks like that signature, but ultimately, how can we establish that it's got any physical attributes whatsoever other than metaphysical attributes like what it appears?
That's a great question, and I would say the answer is solar filters. You've seen all the footage. I mean, you've been in this arena for a very long time, and it's not just NASA. You could, and if you join an astronomy club, chances are somebody with the most expensive telescope has probably some really, hydrogen alpha is the name of one filter. There's probably a bunch of other filters where you can literally see the undulations and then the plasma and the prominences and whatever the things are that they are called, the sunspots moving across. So you can actually, it looks like a ball of fire. I mean, I'm not saying it has to be a ball of fire, but if it looks like a duck and quacks like a duck and swims like a duck, so there doesn't seem to be. Go ahead.
I don't agree that it looks like a ball of fire. I know that's how it's described, and I know that when you say that, people will sit there and go, "Yeah," like conservatives in the Houses of Commons, right? So they'll go, "Yeah, it's a ball of fire." But when I see it through a telescope, it just looks like a yellow spot or a whitish yellowish. I don't see any balls of fire around that. I don't see prominences from that. I don't see anything from it that indicates it's like that.
Right. That's because you don't have a $20,000 telescope, and neither do I.
Ooh, that's a problem, though, isn't it? Because
go ahead.
That's a problem, because if it needs a $20 million telescope to be able to see these things, that's putting it squarely in the Narnia territory, isn't it? Like when we're looking into Narnia, but you need to have this special device to do it. The reality is, when I look up at Saturn, I look at what looks to me like an eye in the sky. It looks literally like the eye, and what you guys call the rings of Saturn is the outside of the eye, and the blob in the middle, the pupil, is the ball that you say is a gas giant in the vacuum of space, which I find that ludicrous. I'm more likely to interpret or perceive Saturn to be proof of creation from the biblical context. It's God's signature in the sky. And right now I'm thinking Werner von Braun's gravestone, or his tombstone, where he says, "For the heavens declare the glory of God, and the firmament showeth his handiwork." Right. Yeah, this was the leader of NASA, and I'm thinking that to me would be the absolute everything that is the epitome or the antithesis of somebody that was researching space. Because why would he even reference the firmament? Surely he would say something like heliocentricity is the most beautiful signature of mankind, or something philosophical like that. Yeah, he talks about the firmament and the glory of God and all that. And I'm like, I'm not a biblical guy, but I acknowledge that when Werner von Braun's saying that, he's leaning towards creation. And I'm thinking, yeah, they look like signatures in the sky to me. Saturn looks like an eyeball. It can't be a gas giant in a vacuum of space, because the gas presses out evenly in all directions. Whatever it is,
yeah,
whatever it is, I don't know what it is, but I do know what it's not, Charles, because I know that you can't have a gas giant in a vacuum.
Okay, so we're not going to go there because our focus is on the sun, but I do want to just clarify on that Werner von Braun headstone quote, that the word firmament is a translation. And so there are many translations of the original. I don't know what the language was, whether it was Greek or Latin or whatever.
It means dome, doesn't it?
Well, no. The word could be also translated as expanse. So when people say the glory of God in the heavens, you could say the word heavens, you could say the word expanse, you could say the word firmament. If you look up at different translations of the Bible, they can use the word expanse. I don't want to argue that point, but what I'm going to say is
do you know how? Do you know how to actually look up the meaning of a word used in the Bible to understand its meaning?
Yes, there's tons and tons of resources available. Like with just one click, you can retranslate it. Like you could see 100 different Bibles. I don't want to focus on that. All I'm saying is that one interpretation is that he's talking about a firmament, aka a dome. Another interpretation is he's talking about the expanse, which is the universe. So, I don't want to argue the translation of that quote, okay?
But if we're going to play that game, though, I can equally say, well, you guys change the meanings of words to suit your narrative.
Give an example.
Gravity is not a force, but you can think of it as a force.
Well, that's not changing the meaning of a word. You can have one word, gravity, and it can have definition 1, definition 2. You're not
Sure.
changing the meaning.
But in
Somebody can
physics,
say gravity is a force, and somebody can also say, well, no, it's really an acceleration. Someone else could say, well, really, and
Yeah, but
according
the
to
problem
Einstein,
is the problem is whatever gravity actually is, it is continuously and intentionally misled and misinterpreted by you guys on purpose to deceive people. Gravity is defined as an effect. Okay, it isn't defined as a force. Yet
yeah.
everybody in your chat right now will be going, "Yeah, gravity is a force," and Einstein says it's not. So
Well,
what you're doing right now with regards to changing the meaning of firmament is exactly what you do with changing the meaning of gravity.
I'm not changing the meaning of firmament. You can look it up yourself, and
Yeah,
but I want to stick.
it's a translation from the word dome. Then I'll just say it's a translation from the word dome, just to be
No,
contentious.
the word dome is not the starting point, because
And
dome does
neither
not
is
translate
expanse.
into
Neither is
expanse.
expanse. You're only saying that to make your delusion sound practical.
Well, I'm not a biblical scholar. You're welcome to look up that point, all right? And just play devil's advocate. Just say, hey, is there any truth to the claim that this thing could be translated in multiple ways? One of which says firmament, another one of which says expanse. Anyway, can we move on? Because I do not want to argue
So the question I
biblical
asked was,
translations.
how can we establish that the sun's got physical attributes to it?
Yes. So you made a point about, I said 20,000 and then you changed that to 20 million. That's 4 orders of magnitude. You do not need a $20 million piece of equipment, a wardrobe in Narnia, to see the sun. You just need a fairly expensive filter, right? A fairly expensive filter, which will show you, it cuts out all the, I don't know, different frequencies. The filter's very expensive, but I don't think the filter is $20,000.
I've not got it in here. The point was, I take your point. I might have said the wrong number, but my point was that if you need the special fantasticness to establish that the sun has got, what did you call it? What was the phrase you used?
It appears to be a ball of fire. It appears to be a ball of fire if you look at it through the right filter.
I don't agree with that. If you look through the Narnia filter, it looks like a wardrobe. Come on.
Do you have an example of a Narnia filter?
Yeah, I could just make one up. Look, I've got a Narnia filter here. I paid $3,000 billion for it, and it was taxpayers that did it. And if you've got this, and there's only one of them, right? If you've got this, then you can see the core of the sun.
All right. So I'd be happy to take you up on that offer, but I think you're just, you're playing, a word game. But the filter that is used.
No. The point I'm making is that if it requires expensive equipment, so it becomes unattainable, unobtainium in that avatar. That mystical, what was it? That magical material was called
unobtainium.
Yeah. So essentially, a lot of this so-called science is unobtainium because we don't have the money to be able to validate or verify anything that is claimed by science. And really, we all know it's not really science, don't we?
Okay. So Anthony, I think you're confusing the fact that a piece of filter, which is like a little piece of plastic, which might be expensive, you're equating that with unobtainable. It is not unobtainable. It is absolutely not unobtainable. You can go to Amazon right now and you can order this filter, and maybe it'll be a couple $100. I know they're not cheap.
Yeah, but listen, if you could ever show me actual evidence of the sun looking like a fireball through one of these filters.
But you've seen it. There's a million videos on YouTube.
I've seen computer generated images of what NASA tell us is the solar fireball.
So, okay, let's move on. Do you mind if I jump into my point number 2?
Sure.
So my point number 1, just to recap, my point number 1 was that if you determine whether the sun is local and then the sun size throughout the day, and this is something everyone can do. So point number 2 is, are we standing on a sloping surface? And again, there are several areas of exploration. Method number 1 is dealing with angles, with the angle of the sun in the sky. And then method number 2 is the wagon wheel effect. So again, it is canonical in any flat Earth map or model, even if there's no map or no model. If it's flat, up is always up. Everyone's flagpole is parallel on the flat Earth is another way of saying that. So if we could determine slope, and that especially if my slope is different from your slope, well, then that shows that the Earth cannot be flat. So let's take a look at the point number or exploration number 1, the sunrise angle. So this is a very famous shot, a very moving shot. You know, Luke Skywalker getting a little misty-eyed on Tatooine. And so what you can do is you can literally measure, and I have a whole video on this, you can literally measure the angle the sunrise makes with the horizon. And it's best if you do it on the equinox, but it's actually pretty accurate most of the year. And if you measure that angle, and then this is a clip from my video, then you can do some math with it. Now here are several example angles. So my understanding is that you're not far from London. There's Miami, Quito, which is right on the equator, Sydney, and then Christchurch, New Zealand. The sunrise is rising at different angles. Whereas, you know, if the Earth were flat, like, again, it's canonical that the sun is traveling parallel to the plane of the Earth. So if you, and again, I'm just grokking this together to making all these sun paths kind of move in the same direction, then you might end up with something that is not quite flat, right? And then the second part of point number 1 is the angle at solar noon, the angle of the sun at solar noon. So again, very similar demonstration, London, Miami, Quito. And this is sort of a side view. So north is to our left, south is to our right. We are facing east on each of these little diagrams. And then if you can, you know, kind of say, okay, well, you know, the Earth is flat, so we're going to put all these points out. And then I'm going to say this diagram is to scale. All the latitudes are exactly evenly spaced, and all those angles are accurate. And those angles represent the actual appearance of the sun on solar noon on the equinox. Okay, so this diagram is not. This diagram is to scale. This diagram is not distorted in any way. Or the alternative, and again, I'm not trying to prove the globe. I'm just trying to illustrate, because I don't want to beg the question. So I'm not proving the globe by using the globe. I'm just illustrating that, again, this diagram is to scale at every single latitude. The sun appears at that angle. Now, point number 2, which is on wagon wheel sunspots. So again, we're using this globe just for illustration purposes only, but this is kind of cute. I've never seen anybody else do something like this, so I don't know if I'm treading new ground. So we got Mario, and he's standing in the UK. I put him in the UK for you, Anthony. It's me, Mario. So he's watching the sunrise. Now, what we're going to do is we're going to look over his shoulder, right? And so he's standing on a sloping surface. He's looking at the sun, but up on the sun is just up. The sun's up is the up for the solar system. But if you look at Mario's perspective, the sun appears to be tilted to the left. Likewise, 12 hours later for sunset, again, he's in the UK, but now he's facing west. It's midday in the United States, but it's sunrise or it's sunset in the UK. And again, up is up for the sun, but if you look at Mario's perspective, the sun appears to be tilted to the right. Now, the interesting thing is that I made a video on this, 5.5 years ago. And so I demonstrated all this. The up for the sun's path is different for up for observers. We always think in terms of up as being perpendicular to the horizon. And the interesting thing is that literally a month after I made my video, Phuket Word made a similar video. And you'll notice his graphics. He's illustrating what it might look like in the UK, and it looks very similar to what I'd put in my video a month earlier. But he actually filmed the sunspots, and so it's very hard for you guys to see. So I'm just going to highlight them. There we go. There's a couple sunspots, and the sun is in fact rotating, in 4.5 hours. Or at least appearing to rotate in 4.5 hours. And also in my video, I included what would it look like in the tropics, like close to the equator. The sun would basically go straight up from the horizon, but then if you face west, the sun is going to sort of flip over. And so again, Phuket Word, this is his diagram. It's like, where did he get that idea? I'm just teasing. I love Nick. He's a good guy. But again, he actually filmed the sunspots, which is something I did not do. But he filmed the sunspots. It's very hard to see, but it's kind of like a little barbell looking thing. So let me highlight it. And it was at the top in the morning, and then it's at the bottom in the afternoon. So So again, my thesis is that we've got lots of evidence that we are actually standing on a sloping surface by examining the sun. Okay, Anthony, that's it.
Okay, so do you want to go back to the beginning of those? Because I've made some notes whilst you were going through them. Just go back to the first one that you showed.
Okay. The one where I posited the argument.
No, sorry. The first one in that section then to do with, that one. Okay.
Oh, the Tatooine?
Yeah. So just confirm for me, when we look at the sun, whatever that sun might be it physicality or otherwise, are we observing the sun in its actual position, or are we observing the sun in its apparent position?
Oh, yeah, it's apparent, obviously, because we have to see it where we can see it. So, yes, the sun could be deviated, and we see the distortions that, like on the beach at sunset, when the sun looks all blobby, clearly there's distortion there. Sure,
but see in that picture bottom right there, you've got the white sun above the red sun.
Right.
And they tell us, according to your model, that when we see the sun and it's getting towards the horizon, the sun is actually already behind the horizon and it's already below the horizon.
Yeah, we see it half a degree.
Yeah, we see it above the horizon, but it's already gone below the horizon, though, right?
Yes. So, in other words, it's displaced by 1/2 of a degree. Yes.
So how does that matter? How does that affect the? Because you said about you can measure all the angles. If we're measuring an angle to an apparent object that's not in its actual location, how does that affect the results that we think we are collecting when we are collecting all these results? Because we're not actually measuring the sun, we're actually measuring an apparent sun in an apparent location, correct?
That is a great question. So I would recommend that you not do this right when the sun is like blobby on the horizon. I would pick, 30 minutes after sunrise, and then go from there. So that's a great question.
The only position where it's actually in its actual position is when it's zenith to you, right? Directly above you. All other positions are varying degrees of non-actual.
Now, do you know what the value of those varying degrees are? Like, do you know how much the deviation is?
Well, when it's over 93 million miles, you only need a midge's dick before it becomes miles out the other end. So
forget the 93 million miles. I'm just saying, do you know what the deviation is at other parts of the sky?
Yeah, it varies depending on the amount of refraction at the time.
Sure, but just give me a number in degrees.
Well, you said it yourself a minute ago, 1/2 a degree.
But that's exactly on the horizon. If you go 10 degrees above the horizon, it now drops to maybe a couple arc minutes.
Sure. Now this is what Sly Sparkane did recently. I don't know, you might not have been here at the time, but he did was it about 10 or 12 different people that were observing the sun and measuring the angles to the sun.
Okay.
I'll come back to the word angle in a minute, but what I noticed with his results is two things. One, he had two erroneous guys that you would look at them and say, yeah, they just made a mistake. But the problem is, if they made a mistake, the effect of making that mistake over 93 million miles is absolutely huge. So I would say, why is the two erroneous ones? Or they just made a mistake? Okay, fair enough. But all of the other ones, they didn't line up either. They were close, but they weren't perfectly. And that's just refraction. But over 93 million miles, Charles, that makes a massive difference. And a lot of those lines of sight to the so-called sun wouldn't actually hit the sun over 93 million miles. It looks like it when you do a very small thing. But when he did his pictogram thing with his graphs and his lines, he didn't show whether they actually hit the sun at the other end of the 93 million miles or not. And they clearly don't. Yeah. So when you say, do you know how small those thingies are? Your question really should be, do you know how small they are over 93 million miles? Because then it becomes massive.
Yeah. Well, but then you're going to turn it into a cartoon. Let's say we don't know how far the sun is. We just know the sun is really far away, right? Because a lot of times people like to make a big deal about, so many miles, et cetera, et cetera. And it's like, but if you're standing in one spot and you're looking at a slightly deviated from where it actually is, the question is, how many degrees? How many degrees is it off?
Right. So because if you're off by half of, let's just say you're off by half of 1 degree.
Yes.
Over 93 million miles, half of 1 degree, you're going to miss the sun completely. Would you agree?
But you're not trying to hit the sun. You're not trying to shoot a bullet at the sun. Okay. So we're not trying to hit the sun. We're just trying to look at the sun. And if the sun is deviated from maybe half a degree, and like I said, as soon as you go 10 degrees above the horizon, the error drops to nearly zero.
Yeah, it doesn't matter though. It doesn't matter. The point is that when you've got an error, regardless of what causes it, be it refraction or human error, when you've got an error and that over 93 million miles, you need to be a little tiny, a minuscule amount to be out a lot at the other end. Do you know who Cara Diane is?
Yes. She
So
set up my message boards for me, which I
yes,
kind of
so
abandoned.
she illustrated how the equinox works using stellarium, but she showed that in the four corners, so like top left, top right, bottom left, bottom right, she showed that they were out by up to 1.5 degrees when it was claimed that the equinox shows the Earth, the sun rising due east and setting due west for every observer on the planet. Yet it was 1.5 degrees out. Now,
Yeah,
if you're
well,
1.5 degrees out over 93 million miles away, that's miles out, Charles.
right. I totally get that, but I think you're confusing like trying to hit the sun. Like for example, if you were a sniper and you're like, I'm trying to hit this target, but that target might actually be it's only a half a degree. Well, at the distance of the target, you're going to miss the target with your bullet. So I get that, but we're not trying to hit the sun. We're just trying to picture where it is. Now the thing about let me just make the point about this, the Cara Diane, which is the sunrise due east and due west. You start getting more and more errors when you get closer and closer to the poles, either pole. So if you're in Scandinavia, you're not going to see it exactly due east. It's going to be off by a degree.
Then the claim is, every observer sees it due east is not actually correct, is it? Because there is error in that.
Well, why don't you round it to the nearest 2 degrees?
No, but over 93 million miles, okay. 2 degrees is a lot.
But we're not talking about at the target. We're talking about where we see it. And the point that I'm trying to make to you is that on the flat Earth, I mean, again, we don't necessarily have a flat Earth map or a flat Earth model, but it's kind of hard to picture where, like, for example, the sunrise and sunset. I'm trying to page through my slides to get to the right slide.
Sure, but you do realize that what you're doing there is you're trying to give me a straw man argument that I'm not making. We don't. Do you know what? We deliberately avoid making model claims because we don't want to reify models into existence like you guys do.
Well, but reification is inappropriately applied in the flat Earth debate.
How so? Explain. What is a reification?
It's where you take a concept that is an intangible concept, like honor or liberty. Like you talk about liberty, and then you have the Liberty Bell, and you say the Liberty Bell is actually liberty. And it's like that's a reification, and that's
okay. So is space-time a concept?
That's a tricky one. It's both a concept as well as like if you believe like if you follow the theory and I don't meaning I don't have any knowledge of it. I just seen
Charles,
a Wikipedia entry. But
Charles, by definition, space-time is a concept and it exists mathematically, right?
Yes, so I will agree with you there. I will agree with you there. But it's a representative of something that's in physicality.
No, no. That's a violent. See, you're reifying. If you treat something if something's conceptual and you're treating it as a manifestation of something in reality, that by definition is reification. You are making something physical out of something that's conceptual.
Right, but the concept, what we're talking about, if you look up the definition of reification, it talks about the concept as being, completely 100% intangible, like the concept of liberty.
Like a model.
No, not a model.
Yeah,
a model is
like
a physical thing.
Like a heliocentric model.
No,
a heliocentric model is completely
that's a physical
intangible.
thing.
No, it's not. It's not, Charles.
I mean, it's a model. I mean, you could build it. There's orreries. You could build it, but it is a model.
But if you then use that and claim that that's how the world in which we live because the model represents it, that's reification. That isn't the world we live, Charles. You're making a concrete noun out of an orrery.
So, getting back to the point, because I think the point gets derailed a lot. So you made the point that like Cara Diane said that in the corners you get a significant error. You made the point that Sly Sparkane had a bunch of volunteers and some of them were off, and it's like okay, so I'm gonna say off by how much? I've got this banner, Relativity of Wrong by Isaac Asimov. But again, if the claim if somebody is claiming Joe Schmo is claiming the Earth is flat, well, where are all these sunrise and sunset angles? Well, they're pointing.
No, I never claimed. My point was that when Cara Diane demonstrated it using stellarium, she was out by 1.5 degrees in several places.
Okay,
that's not possible for the claim that everyone observes the sun rise due east. Because it's not, is it?
Okay, the sunrise due east, it's not 90.000 degrees azimuth. Nobody made that claim. But due
Yeah, that
east,
is
for
the claim, though.
example,
That is
for
the claim.
no, it is not the claim that it's 90.000 degrees
So then
azimuth.
it's
No
not
one,
due east, is it? It's
no,
not due east, then, is it?
okay. So most people, when you look at a compass rose, there are four main directions: north, south, east, west. Well, then you can get four more: northeast, southeast. Well, then you can get that's a total of 8, right? Now you can get 8 more: north by northwest, right? The movie.
Sure.
So now you have a total of 16 directions, right?
Yeah, but
16
there's only
directions,
one
and now
due
you could.
east. There's
No,
only one due east.
right. But out of these 16 directions, one of them is due east. So
Correct.
1/16th, and then
So the
Cara
claim is that
Diane's
all
claim
observers.
is irrelevant.
So the claim, no. The claim is that all observers observe the sunrise due east on the equinox. However,
Out of the 16
it doesn't-
directions.
there's only one direction that's due east, Charles.
Out of the 16 directions.
There's only
right.
one that's due east.
That is correct. And do you know how
And
big
they,
that?
and they don't all observe sunrise due east, Charles.
Okay.
So the claim doesn't match the claim. The
okay.
evidence doesn't match the claim.
The point, and I'm grabbing my calculator here. What is 360 divided by 16? So if you divide 360 degrees of azimuth into 16 parts, such as like north, and then you have north by northeast, and then you have northeast, and then you have
Charles,
east
just give me 2 seconds.
by northeast, right?
Just give
And
me
then-
1 second. Let me get a quick drink. But I can hear you, so keep talking.
Okay. So if you divide 360 degrees of azimuth into 16 equal parts, which includes not just north, south, east, west, not just northeast and southeast, but like things like north by northwest, right? Then each direction covers 22 degrees of observation. So in other words, you could divide it into 32 divisions, and you still can have the claim that sunrise is visible due east, because the error that we're talking about, Anthony, the error, quote unquote error, is 1.5 degrees or 2 degrees. I forget what you said, what the quote was. That is not a whole lot. But the point that and the reason why I've got this on my screen is, if your error is just a couple of degrees, what would the error have to be on I know you're going to say reification model, flat earth model. Try to pick a flat earth model. Like what are the errors that we can see on the screen right now?
For the claim
It's
to
like
be
60
true,
degrees, 60-degree error.
for the claim to be true that all observers see sunrise due east, it can't be 89 degrees or 91 degrees or
Why not?
91.5.
Why not?
Because by the time it gets to the sun, 93 million miles away, it's missed by shitloads.
We're
It
not
matters,
trying to hit the
Charles.
sun. We're not trying to hit the sun.
So it's not due east then, is it? We're seeing the sun in some other position that's not 90 degrees from north.
Okay, so this is really important that we address this point, because there is a wonderful essay by Isaac Asimov called "The Relativity of Wrong." You can Google it, and the relativity of wrong talks about how, just exactly what we're talking about here, where we're saying the words due east, but you're taking that to mean 90.000 degrees. Like if it's
that is what due east is.
90.0001, you're going to say, well, that's no longer due east.
Yeah, of course. It's
And-
not
and
due-
so-
yeah, but we're not talking about 0.1, are we? We're talking about a whole degree.
Right.
And a whole degree over 93 million miles, Charles, is a lot.
But we're not trying to hit it. So the point that I'm
No,
trying
but
to
we
make
are trying
is,
to. No. We're trying to support the claim that all observers see the sunrise due east on the equinox, and that's not true.
but you got to define due east. I'm going to say due east is
90 degrees from north.
is and I'm going to say within, if you round to the nearest pair of degrees, right?
So what
It's
you're going
not-
to do is change the definition of due east, and you're going to say due east plus 1 or minus 1 is okay.
Well,
I'm going to say it's not. You're changing the definitions again.
I'm not changing the definition. I'm just giving error bars. And the thing is, the thing you have to understand, Anthony, is that the deviation from due east on the equinox is actually predicted by the heliocentric model. It's not
No,
like
it isn't.
there is some
No, it's
error
not.
that we see in the real world. Therefore, the
On the
heliocentric.
on the heliocentric model, it is 90 degrees due east for everybody.
It is not.
Because-
You have clearly not studied it, and the reason why it's not, Anthony.
Oh my God.
Anthony, and I've got a whole video on this. The reason why it's not is because, and I'm going to try to. I don't have a circle with me. I do have a circle. I'm trying to figure out. All right, so here's our horizon, and it's like when the sun is setting. This is an ocean horizon. When the sun is setting, we don't measure it here. We don't call this sunset, but this is where the center of the sun is at the horizon. We measure sunset when this happens. Okay. Well, that shifts a whole lot towards the
Charles,
poles.
you do realise
Okay.
that the east and west and the north and south are over the horizon. They're not to do with the position on the horizon. It's to do with its latitude, or its what's the word I'm looking for? It's the bearing that you're looking at the middle of the sun at. That's what we're talking about.
Right, and that bearing deviates slightly further you get to the poles. Because
not according to your geometry, it doesn't.
Yes,
Which brings me to
absolutely.
My next point. Brings me to my next point.
Okay.
So do you want to go to your next slide?
Okay. Just tell me the that
Next
was
one.
the whoops, we haven't got sloping surface. We covered this one, right? Yeah. So which
Stop. Go back. Right. So I think it might be one more we may end up. You're right. See this one here? You said equinox angles. You're right. So you got due east, and then you got theta, and then you got an angle, right?
Yes.
So obviously you're aware of the claim of the sextant, right? It's
right. This is not a sextant observation.
No, I know that, but the point that the sextant does is it measures an angle, right? Do you acknowledge and accept that a sextant measures an angle
between two visible objects? Yes.
Correct. So when it measures an angle, it uses a vertical, it uses a horizontal, and then it uses a line of sight, and that's where you get your angle from.
It does not. Sextant doesn't do any such thing. So,
my God.
Yeah, no. To be clear,
what do you think a sextant does?
Can you use a sextant horizontally? The answer is yes. Can you use it diagonally? Yes, you can use a sextant.
But when we're measuring the angle of the sun, Charles, where it is on the horizon, the angle.
But that's not what's on the screen.
Hang on, we're using two straight lines, whether they're horizontal and vertical or vertical and horizontal matters not. They're two straight lines. Is that correct?
No.
It is, Charles.
No. The sextant.
Oh my God.
The sextant, and I've got a whole
okay,
sextant
tell me how
project.
You're going to measure the angle. Tell me how you're going to measure the angle.
On the screen?
In any of these observations to do with the sun.
But how about the one on the screen, right?
Okay, what are you going to use? You
can use, I used Keynote. I used Apple Keynote. I literally drew a line on the screen and I measured the angle of that line.
Was the line a straight line, Charles?
Well, I mean, I drew it on the screen right now. Do you see it? It's a straight line.
Straight line?
Yes, it is a straight line.
Is the other line a straight line?
Yes, I tried to align that with the horizon.
Okay, so we're using Euclidean geometry, are we not?
Oh my goodness. This is a flat 2D photo. All right.
Yes.
Or it's actually it's a time-lapse photo. But
it's a yes/no, Charles. Are we using Euclidean geometry? Yes or no?
Yes, we are using Euclidean geometry with this.
Are we using curvilinear geometry at the same time? Coordinates. No, we're not. So what coordinates are we using?
What do you mean by what coordinates? I'm just measuring an angle on a photo.
Yeah, the angle. So the points that make the line, what is that coordinate system that we're using? If it's not curvilinear, what is it?
Well, I mean, the Euclidean works fine. You know, you can.
That's the geometry.
Right. Of this 2D photo. It's a flat 2D photo, multiple exposure photo.
What's the coordinate system that we're using for these points
Cartesian?
in the sky?
I mean,
correct.
But you could also use polar. You can use polar coordinates. But
why would you be using Cartesian coordinates and Euclidean geometry when in your model we use curvilinear geometry and we use curvilinear coordinates?
I think you're confusing this 2D photo with 3D space on the surface of a sphere. I'm not talking about 3D space.
I think you're confusing the geometry and you're using the wrong tool to measure the wrong thing in the wrong set of geometry.
So, but the comparison with this photo.
Can you respond to that, please?
But what would you expect on any other model? For example, a flat Earth model where the sun travels parallel.
What would I expect on your model? Because in your world you use curvilinear geometry, I would expect to see two curved lines, and I would expect to see an angle based on two curved lines.
Well, then you don't understand straight lines. You don't understand our model, then.
So you deny that your model is curvilinear geometry and curvilinear coordinates.
You can use any kind of coordinate system, any kind of geometry you want for any of these situations.
The problem is, Charles, you're using two straight lines and you're using Euclidean geometry and you're using Cartesian coordinates.
On this photo.
Your model doesn't have that.
It's just a photo.
I know it is, but your model doesn't have Cartesian coordinates. It has curvilinear coordinates.
No, it's a
your
photo.
Your model doesn't have Euclidean geometry. It has curvilinear geometry.
It's a photo.
Yeah, but you should be applying your geometry to the photo.
I am. And when you apply geometry to a
You're
photo, you
applying
can use an X
Euclidean.
and a Y. You can measure angles. Okay.
You're using Euclidean geometry in a non-Euclidean geometry world in your model.
I think you're confused about the model. I'm very.
It's
I'm
because
very,
you don't understand. You don't understand the model.
oh my goodness. I understand the model. So
Listen. I understand that Einstein tells us that because of the Earth's maths, it bends space-time around the Earth. So all of your lines looking out towards the horizon in any angle that you want, they're all curved lines. That's non-Euclidean, and that's curvilinear geometry, right?
I'm not going to argue
straight lines.
I'm not going to argue Einstein. All right.
Because you don't understand your own model. You want to use Euclidean geometry to make a point about the sun, but that's our argument. You're using our tools to measure Euclidean geometry and use Cartesian coordinates to do it.
Okay,
but you're supposed to be using non-Euclidean geometry.
Why?
And because that's what the world is that we live in. Apparently, it's a non-Euclidean world according to current science, Charles. I thought you were up to speed with this stuff.
No. So Anthony, you've taken lots of photos. If you take a photo and you open it up on whatever software you use, whether it's Photoshop or, I mean, I do actually a lot of stuff with Keynote. I mean, it's really crazy, but I never really learned Photoshop. But when you open up a photo on Photoshop, you've got pixels. You've got an x-axis, you've got a y-axis, you've got, you can measure angles.
They're all Euclidean devices used to use. Like if we lived on a plane, Charles, you would use Euclidean geometry and use Cartesian coordinates.
So,
according to you, we don't live on a plane. We live on a curve, and in that curve, we've got to use non-Euclidean geometry with non-Euclidean coordinate systems, which you were not showing on screen. You're misleading your own audience, Charles. I thought you knew this stuff. You are.
So I don't want to have this thing go too long. Can we move on to my third point, which is, are we standing on a rotating body?
As long as your audience understand that you're not using the correct geometry and making a point about geometry that's invalid in your model, yes.
Okay.
So can we go to Mario? Can we go to Mario?
We already passed by Mario. Can I just run through, because the thing is, I just want to be mindful of the time. We can go over.
Okay, so just one line for Mario. If Mario was, instead of turning around and following the sun or the moon, like cartwheeling over the sky, if he maintained his orientation and arched his back instead and bent over backwards, then it wouldn't do that. The reason why it's rotated is because he's turning relative to it. If he keeps himself the same, arcs his back overwards, the sun's in the same, or the sun and the moon are in the same position as what they were when they first started. They've not rolled.
So the only thing that would happen here, facing west, is that he would be doing a handstand, but he'd still be facing west. His horizon is still going to be horizontal. The sun is still going to be at that orientation.
If he bends his back backwards and he still observes the sun, rather than turning around and looking the other way, so
the sun will have still rotated. The sun will have still rotated.
Okay. Move on to your next point.
Okay. And let me just fast forward to my slides. And oops, I color coded them so that they'd be easy to spot. Okay. So my next point is: are we standing on a rotating body? And we can examine the speed of the sun through the day, and then we can also use sundial observations. And again, it is canonical in the flat Earth model that it's flat and stationary, and that the sun moves above it. So there's lots of ways. I've got a video on this. I've got a video on everything. But you can measure the sun. You can measure the speed of the sun. And when I say speed, I mean apparent speed, visual speed in terms of arcs.
Sorry to interrupt, Charles.
Sure.
Did you mean that literally? You've got a video on everything?
I do not have a video on everything. I was trying to make a joke.
Okay.
I have lots of videos, and I'm trying to show you excerpts of them because I try to focus on DIY, how people can do their own stuff in their own backyard. So this is an example. Literally, this was a cardboard mailer for my Gleason's Flat Earth map. when it was shipped, this is the cardboard box that it came in. And so I just turned it into a pinhole viewer. It's not exactly a telescope, but it's almost like a telescope for viewing the sun. And then, you could see that little spot of sun, and you just kind of, I took a photo of it, and then I waited a few minutes later, I took another photo, and then you can measure the speed of the sun. And then the analogy is that if the sun were actually traveling in a flat plane above us, at a constant speed, obviously the sun's going to travel at a constant speed, what would it look like to an observer? Well, it appears to move faster. It would appear to move faster the closer it is to us. So the question is, do you see the sun moving faster closer to noon? And you could explore that on your own.
The answer is yes.
Well, I would love to see the observation because I
could do it for you now. So you can do it with, like, you asked specifically about the sun.
Yes.
So would you accept that if I showed you, say, for example, the stars, would you accept that the stars are not going to be... So would you accept that the stars slowing down as they get towards the horizon, would you accept that that is consistent with a flat plane and convergence? It's not consistent with an Earth that's rotating, because if the Earth was rotating, it would be a linear function and there would be no change in speed. But if the Earth's flat and it's converging, they would slow down as they get to the horizon because they are doing exactly what you say. They are getting further and further away and they are slowing down because of it.
I disagree, because with the celestial sphere, in the heliocentric celestial sphere, the stars are, obviously if you're looking at the due east horizon, the stars will rise and the stars will set, just like the sun and moon rise and set.
That's right, but it's the rate. It's the rate, because your point
right. No, it's not going to be like 15 degrees. It's not going to be 15 sky degrees. And I want to clarify this for you and also for my audience. If you use a theodolite and you say the distance between this star and this star is 15 degrees, I'm going to call that 15 sky degrees. The stars do not move 15 sky degrees an hour away from the celestial equator, because just like you said, they're circling around Polaris, right? And as they circle around Polaris, they're only moving like, a star that might be moving this fast further from Polaris is only moving this fast close to Polaris, but it still is moving at that same, if you put a clock up there, it's still moving the same angular speed where the angle is measured from Polaris.
That's wrong. They slow down as they get towards the horizon. You say there in your slide, constant speed of object moving towards or away from viewer.
Yes.
And you're saying that is a linear function. Agreed?
No, it is. It's not a linear
saying it's a
function.
Constant speed.
No. Yeah. It's a constant speed, but we're talking about two different stars. There's a star that's, say, on the celestial equator, like Orion's left hip, right? He rides the celestial equator. But then you've got circumpolar stars like the Big Dipper. Right, those stars are much.
If we see a shower of stars going towards the horizon that are going to dip below, you would say it's going to dip below the horizon. If we can show that those stars are not performing at the same constant speed as you claim they are, would you accept that you might be wrong? Because I can show that they are slowing down as they get to the horizon.
So, I just want to be really crystal clear about what you mean by slowing down. They
converging.
Yeah, I'd have to see that.
I'd
want you to be able to prepare that. So can we?
No, I'd like to do it now. I'll get it up, so it could take me a couple of seconds, but I can demonstrate that your claim that they are moving away at a constant speed is incorrect.
Well, but it all depends on what you mean by constant speed. I mean constant angular speed around Polaris.
Yeah, that's not true. I can demonstrate it's not true.
Okay, please.
Will do.
Do you have like screen sharing?
Yeah. Just give me 1 sec. Let's be really clear before we get this up, because I know you've said it twice, and I want to make sure that we're on the same page. I said to you that when I was citing from your slide, you said that everything moves away at a constant speed. I can demonstrate that things slow down as they get to the horizon, and they are not moving at a constant speed. Now, your counter argument is going to be it's refraction, but the problem with that is you can't prove that claim. The reality is that all the stars slow down as they get to the horizon because they're converging, Charles.
Yeah. Okay. So, the sun slows down when it gets right on the horizon. It all depends. If that is your claim, then that's going to be like a right at the horizon refraction. But we're not talking about the stars up in the sky. And that's why it's important.
I am.
Okay. So if we're talking about the stars up in the sky, not like 1 degree away from the.
Correct.
We're not talking about 1 degree away from the horizon.
Correct.
We're talking about up in the sky. You're saying there's going to slow down. Okay.
Correct.
Okay.
All the way through the sky.
Share
my screen. Share screens. Because this has obviously been Sean Hawkins' claim. Why aren't people taking the Polaris challenge? Well, it's because it doesn't do what he claims it does. So
yes.
if I pull my screen up now.
Yeah, I don't have okay. There we go.
So I'm citing from Mick West. This is your alma mater, right? He's your holy. He's the prophet.
I graduated from Mick West University.
Yeah, the prophet Mick West. This is right. So I'm going to show you now what Mick West demonstrates in this video. Now he calls this caused by refraction, right? Now what he's showing here, if I Let me just knock off the sound. Where's the mute button? I don't want the sound coming through. There it is. Let's knock that off. So what he's showing here, if your claim is correct, that everything goes at a constant speed, then all of these stars that are falling towards the horizon because of Earth turn, they must be falling at the same speed, correct?
Yeah, but when you get to the horizon, yes, you're going to, I mean, within
Not
a few
when you get
degrees
to
of
the
the
horizon. Not when you get all over the sky. They slow down as they get to the horizon, Charles.
I don't
Okay.
believe, not unless we're talking about right close to the horizon where you've got significant refraction effects.
No, it's not right towards. Oh, I think
Because I mean, I've seen the whole thing where it gets all, they get all wiggly close to the horizon. But this is shot with a telephoto lens, so we are zoomed in. We are definitely zoomed in.
Sorry, I brought the wrong video up. Forgive me. That was the wrong video. Let me play this video because this is the one that I want. Knock the sound off, and then he uses the same video anyway. It's referencing the same video.
Yeah.
So what he's done is he's brought all of the stars in question and he's plotting them into his Photoshop thing.
Right.
And what he's doing is he's taking them every second interval. So that let's get rid of that. So he's plotting where the star is every second. So that you get a frequency, because your belief is that everything's going at a constant speed.
Right.
So what he's then going to show is where it is exactly after 1 second and where it should be after 1 second. So he's got all the green lines to represent a full second, but then he's got the blue lines to show the blue ones to show where the stars actually are. Now, I accept your point is only above the horizon, that little tiny bit. This is the whole sky, Charles. They're slowing down as they get towards the horizon. It goes completely against the rotation of the Earth claim because they're not meant to do this on your model. It's meant to be linear. It's meant to be constant as you claimed, but we're now going to show that it's not actually constant. It's slowing down.
So the problem is that, remember how I said that we weren't supposed to be talking about right against the horizon, right up against the horizon? We are now 0.004 degrees. Each one of those green lines, each one of those green lines, if you measured the angular distance, that's 0.004. That's 4,000th of a degree.
Well, there's
so
a mountain
we are right
at the bottom,
on the horizon.
Charles.
We are right on the horizon.
No, we're not. No, that's not true.
Did you say each of those stars is 1 second apart?
No. Look, there's a mountain at the bottom of the picture. Can you see the mountain?
Right, and that's there's nothing in this image.
We're not right at the horizon, are we? Right at the horizon is where the mountain is.
How many seconds apart are these lines in the video?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds.
Okay. Do you know how far stars actually move in the sky in 10 seconds?
So the stars do move in the sky, not us move around the stars.
Well, don't change the subject. What
I'm just being careful.
Is if we have 15 degrees per hour motion.
Yeah, but we don't know. That's the point. That's
15 degrees per hour motion. This video represents 4/100ths of a degree. 4/100ths of a degree is represented from top to bottom.
At what distance?
You're changing the subject.
I'm not. You're saying 4/100ths of a degree. We're going from the mountain right up towards the deep blue of the sky. So that's not true, is it?
But that's 4/100th of a degree above the horizon.
Right. Support that claim. Where have you got that value from?
Well, okay. So from our vantage point on Earth, everything appears to move 15 degrees per hour. So whether the stars are actually moving or we're moving, let's just leave that.
You claim that. That's not true.
No, you could measure it. You could measure it 15 degrees per hour in the sky.
Mick's done it. Mick's measured these claims that you're making now. Mick's measured it. He's got it on screen now. He shows that the blue dots are where the stars should be.
Okay,
but they're not. The slippage.
When you said, do you believe, do you agree that the stars are slowing down? And I said, well, no, not unless we're talking about exactly right on the horizon. You said, no, we're talking about right up in the sky. But here's a video. Right up in the sky. Here is a video that is literally the last 10 seconds of a star's appearance before it sets, and that is 4/100ths of a degree. Whoops, I'm sorry, you can't see my calculator. That's 4/100ths of a degree. So we are now 4/100ths of a degree above the horizon.
This is the problem with your maths, right? This is why we don't use maths in science, because your calculations are not correct, Charles.
Can I quote you on that? We don't use maths in science.
Yeah, you can. Where is it in science? Right, I don't want to go on a tangent here, but can you show me where in scientific method it says that you must use maths?
No.
Right, because we don't do it.
Because you can use the scientific method with qualitative data. like a tiger stripes, so you're not going to describe the tiger stripes necessarily with math. Yes, you can use the scientific method with qualitative data.
Can you show me where it shows in scientific method where you use quantitative data, please?
Well, by definition, quantitative means numbers, and you're going to analyze
and
those
it's not
numbers
in there.
with math.
It's not in there. That's why the independent variable isn't a value or a sum or a formula. It is a wiggling and manipulation. So we don't use maths in science, Charles. Again, you're not correct. You don't know your model. You don't know science.
I got to put that on a t-shirt.
Like
we don't use math in science.
We don't use math in science. We use math in physics. Physics and science are not the same thing.
Oh my goodness. Physics is a subset of science.
It's a conversion from the experiment into a mathematical correlation. It's maths. It's glorified maths. That's all it really is.
Okay.
That's because they don't do experiments in physics enough to justify calling them science.
Okay.
Rarely do they actually do it. But the point that we're trying to get here, Charles, is your claim is that the angle of observation that we're observing here is less than 0.0. What did you say?
Let me turn on my calculator again. It is a 400th of a degree.
It isn't, though, because look at how big the mountain is on the horizon.
That's how big
400ths of a
mountains
degree would be less than the mountain.
Haven't you ever seen mountains through a telescope?
Charles, the mountain would represent the 0.04 of a degree that you're claiming.
I don't know what the focal length is. I don't know where the observer is. I'm
so
sure.
Why
all
did you make the claim that it was 0.04 degrees? Then where did you get that number from? Did you just magic it into existence like you did with gravity?
You said this was 10 seconds of video, and so I just took my little calculator and I said, how many degrees would a star move in 10 seconds? A star moves 400ths of a degree in 10 seconds.
No. This is time lapse, Charles.
Of course, it's time lapse. Of course, it's time lapse.
So it's 10 seconds of time lapse, not 10 seconds real world.
Well,
no wonder your maths is so far wrong.
So we would have to determine that. All right. But my claim.
Let's scrub that. Charles, can we scrub that comment from the record then? That's 0.04, because you've just admitted that you don't have that information. So let's not pollute the audience with thinking that there's a massive, like tiny amount here. We've got a mountain in the image that would represent the value that you claim.
Okay.
So we'll scrub that one from the image.
So why don't we table? So Anthony, why don't we table this? I've never seen this video before. I am fascinated by this video.
Great, because what it demonstrates, Charles, it shows that the stars are not moving in a linear format the way you claim at a constant speed. What it shows is they are slowing down towards the horizon.
Okay, slowing down towards the horizon. When you get right on the horizon, I agree with you. But you said up in the sky. You said up in the blue sky.
It's on screen. That's what you said. It's on screen, Charles. It's on screen. There's a mountain in the image for scale.
Goodness. So anyway, Anthony,
Charles, can you scale?
Anthony,
Charles, no, we're not moving from this point.
Oh my
You're
goodness.
going to stay on this point. The stars are not moving at a constant speed the way you claim that they are. They're not.
Okay. My claim was that stars, due to refraction right on the horizon, just like the sun appears to slow down right on the horizon.
That wasn't
right?
your claim.
By a half a degree.
Was that they move at a constant speed and they're
up in the sky.
Slowing down.
I said you got to look up in the sky. We are not looking up in the sky in this video.
Charles, now we're at the point where when I've shown you evidence that you're wrong, you will not accept it. This is the reason why Nathan dwelled on that point for so long.
Okay.
He wanted to know how Eratosthenes knew the earth were a ball.
So
and
don't
you spent 55 minutes. You spent 55 minutes wiggling, and now you're not admitting that you're wrong.
Okay, Anthony, can you tell me the focal length of this lens?
I can tell you that there's a mountain at the bottom of the picture, Charles, and it doesn't represent 0.0 whatever it was of an angle.
So that's no. You cannot tell me the focal length of this lens.
I can tell you that it is bigger than 0.0 of a degree because there's a mountain in the image.
Who's waffling? I'm teasing, Anthony. Of course I'm teasing, right? I'm teasing. I'm asking you a direct question. What is the focal length of the lens in this image? And I know you don't know. I'm not trying to put you on the spot.
But that doesn't matter, Charles. You can see by looking at the mountain that the angle that we're observing is clearly not 0.0 of a degree or whatever it was.
I am not familiar with that mountain. That mountain could be a hill. It could be a huge peak. I don't know what that mountain is.
Charles.
So
Charles, why don't you just accept, be a man, be honest with your own audience and say, there's a mountain in the image, it clearly is more than 0.01 of a degree or whatever.
There's a bump in the image that could be a mountain.
A mountain.
I don't. Okay.
A mountain.
So, but here's the thing, Anthony. I love taking images like this and dissecting them. I go to Peak Finder.
Dodging, doing anything you can to avoid addressing the point, Charles.
Anthony, you're familiar with Peak Finder, right?
Sure.
Okay, so I would, and when we get offline, I'm not going to, waste the audience's time and try to do it live. When we get offline, I'm going to watch McWest's video. I'm going to try to find the source video. I'm going to try to find, where they're pointing. And then I will go into Peak Finder and I will try to line things up and I'll be able to make a wonderful analysis. I just can't do that right now. Can we get back to my last few slides?
Here's the thing though, Charles. You don't need to do the analysis to acknowledge that there's a mountain in the image. It's clearly at distance.
It's a bump.
It's bigger than 0.0 something of a degree.
I don't know that.
Anybody, you do know that, Charles.
I don't know that.
You know
I have no idea whether that mountain is a bump on a golf course. Okay, I'm teasing, Charles. Of course. Can we get back to my?
No, that's called lying. That's not teasing. That's
no.
Lying.
So answer me this. What's the focal length? Go.
You don't need to know the focal length.
There you go. Okay, we got to move on. We got to move on.
Not really. You're just being dishonest, Charles.
So, but Anthony, let's table this until I have time to actually, I've literally never seen that before. I would love to analyze it, and let's analyze it, and then you can make a video. I can make a video. We can have dueling videos. Okay. But can I please move on with just my sunset? This is really the last part of my third point. If you have a sun dial, and when I say a sun dial, it literally could be a toothpick jammed in a pizza box. Then if the sun is indeed traveling in a plane parallel to the plane of the Earth, we would expect some things on a flat Earth. Whereas if the sun is actually going around us, when I say going around us, the Earth turning underneath it, we expect to have a hyperbolic sort of presentation.
Explain to me how this is not a non sequitur.
No, a non sequitur is when you're just talking random stuff. What we're trying to do is we're trying to establish the path of the sun in the sky. The path of the sun in the sky.
Explain to me why this is not a non sequitur. Tell me what a non sequitur is. You said it was explaining random stuff, but it's not.
Well, no, I'd rather not try to define something like when someone says demands you to define something. You tell us what the definition, because you've clearly studied it. What's a non sequitur?
A non sequitur is where the conclusion isn't necessarily logical. It's like, oh yeah, it's lovely that there's a pin sticking through a pizza box, but what is the conclusion that you draw from that when you do that? Well, you say, well, it would seem to match what you'd expect if the Earth were a plane, but you have no idea how the sky behaves. You're doing that based on your own opinion that I would say is non sequitur and doesn't prove anything either way. It's just an opinion at best.
Okay, or it's an interesting set of observations where you cannot conclude anything either way. Okay, but the point that I'm trying to make is that the sun moves in very predictable ways in the sky. And the most surprising thing, I don't know if you remember Pancho Pete, but the one time I got Pancho Pete to shut up and actually think and stroke his chin. Do you remember Pancho Pete from like 4 or 5 years ago? He was the shouty guy.
I've seen him for years. Did he go to jail for stabbing someone online?
I think so. But he was the shouty guy. He was always shouting all the time. And I got him to shut up. I know who he is. I got him to shut up for 1 second. And the thing that I got him to finally quiet down on was when I said on the equinox, the path of the shadows is a ruler straight line. That's that red line across there. And anybody can do that.
Go back.
Yes, anybody.
I can look at that there, right? And regardless of your stick sticking out the pizza box, I can look at that and say that's a function of the light coming through a lens. It's exactly the same as, you're not in England, are you? You're not. No, you're in America.
Yes, I'm in Pennsylvania.
We used to have a program called The Bill, and it was about the police. And at the beginning, they used to have a light. The old style police beacons was a halogen bulb, and then like a satellite dish that was rotating around it, and that gave the whirlybird, right? That gave the projected beam.
Yes,
that reminds me of that, because it looks to me like the light's passing round in that kind of way, and I can see that being totally consistent with perspective. And I can look at that and go, yeah, that looks like there's a light coming round us, and that's consistent with the way our eyes are, because we view the world, and the world is Euclidean. I know you in your model it's non-Euclidean, but we have a Euclidean world where straight lines do exist, but we view them through a curvilinear lens. So that's why we can say, and it's not dishonest to say it if you qualify it properly, we view the world, the Euclidean world, through curvilinear lenses. But if we're viewing straight lines through curved lenses, you're going to get curves that are on the extremes. Right in front of you, it might be straight, but around the sides of you, because it's curvilinear, you're going to get that effect there that we're looking at. And I would say that that's because we've got lens to our eyes, and or the additional lens of something else outside that the shine. Because look at rainbows. You can't create a rainbow without two lenses, right? Well, one lens is coming through the eyeball.
No, you can create a rainbow without any lenses whatsoever.
No, you can't. You need
Yes,
to
you
have
can.
two lenses. You need to have two surfaces to reflect the light off.
No.
So one of them will be the eye,
Are,
but where's the other one?
are you familiar with pinhole photography?
Yes, very.
So and I was a working photographer for many years. I was a photojournalist. So, but I literally have built my own pinhole photographer using black and white film. Okay. But a pinhole camera has a flat piece of film and a pinhole. There is no lines. I'm sorry, there's no lenses and there's no curves. And you could photograph a rainbow with a pinhole camera. No lenses. Okay. So I'm not quite sure I understand your point. But anyway, I get your point about what you say this looks like, and that's great. But this is exactly the hyperbolas specifically. The hyperbolas is what would be expected from a globe model. So again, the question is the third line of inquiry. Are we standing on a rotating body? The speed of the sun is constant throughout the day, meaning 15 degrees per hour around the North Celestial Pole. And then when we do sundials, we get hyperbolic paths with a straight line on the equinox. Now, I just have one final little, and this is just a summary slide of the thing, but I just wanted to have one final thing. The Earth could still be flat, all right? The Earth could still be flat, and I want to show you this, and I think you may find it a little bit amusing. So let's say we take a pole and we put a 20-degree angle on that pole, and then we mount on that 20 degrees Mexico, specifically the Teotihuacan civilization. They died out before the Mayans even got there, or the Aztecs. I think the Aztecs came after them. But anyway, there's no evidence. It was 8 square miles. There's no evidence they explored. So the Earth was flat to them. Let's take another angle on this pole, 42 degrees, but this one's pointing down. And then let's plaster onto that the ancient Tasmania, 20,000 years ago. Guess what? The Earth was flat to them as well. And many ancient civilizations, ancient Greeks, Sumerians, Babylonians, Egyptians, Vikings believed the Earth was flat. And you could say the Earth is locally flat. But what happens, each one of these flat pieces is at an angle. We do see the sun, moon, and stars traveling at an angle to where we are, and that angle changes based on latitude. So if you take this flat Earth here, flat Earth there, ancient society here, ancient society there, and you just get rid of the seams, you end up with a globe. And I rest.
Okay.
Do you want me to show you screen?
Please, yeah.
Okay.
All right, so everything that you just said there, I'm not going to address anything directly on there because it's that anecdotal and historical that nobody really knew what shape the Earth was back then.
Sure.
And I want to address Nathan's question to you a few weeks back because Nathan asked you, how did Eratosthenes know that the Earth was a ball? Because your point was, and let's just clarify this for your audience, your point, and let's be really clear, you've got to know the shape of the Earth before you actually do any testing, right? That was your first point, correct?
Before you measure the size,
you need to know the shape.
Yes.
Yeah. And Nathan's point was, how did Eratosthenes know?
That was not his point.
How did
he
measure it?
I get the R value. And
no, his point was not that at all. His point was not that at all. We know because education teaches children this. This is what Conspiracy Cats teaches children in school right now. He teaches them, and if he doesn't, he should be, because this is the parable of heliocentrism. You can check. You can go to Google now, and you can type in Eratosthenes assumed the Earth was a sphere to get you all the relevant articles, and you can see article after article after article that Eratosthenes assumed the Earth was a sphere. That's where the story comes from. Now, you can say that he believed it because he knew that somebody else did it, or that somebody else did it. But whether that's true or not isn't really important, because the story, the parable that kids get told is that Eratosthenes assumed that the Earth was a sphere. I don't know how children can be taught that when it's an assumption of a position before you start doing the maths. It violates your first rule. Your first rule was that you need to know, but it's reported in education everywhere that he didn't know, that he assumed. So if we then say, well, such and such a body earlier in, like Ptolemy, for example, or whatever, Socrates, somebody else did something else, that's not the current position according to the education. So when you said you've got to know the shape of the Earth first, and I completely agree, when we say, well, how did Eratosthenes know what shape it was before you even start measuring anything? And then there is no answer to that other than he assumed it. So when he's calculating the circumference, and he's using our values to get the circumference, and then from there you can get radius and diameter and all the other bits. Why is he using spherical geometry when he should be using non-Euclidean geometry, and he should be using he should be using Euclidean coordinate systems? So he's using angles to measure the sunlight and all that when he's using the wrong tool for the current position in science. He didn't know what the shape of the Earth was before he did it. And even if he did know the shape of the Earth, we're told in education that it was assumed. And that's what kids get told in the parable of Eratosthenes.
So the word...
I used the word parable intentionally by the way.
Yeah, but the word assume, you could say that's just a hypothesis, which is a central part of science. You could also say, based on all the evidence that he had at the time, the conclusion was that the Earth was a sphere. And you could still call it an assumption because Eratosthenes did not go flying in the space shuttle and then orbiting the Earth, from the vantage point of space and say, oh, look, I see it's a ball, right? So Eratosthenes couldn't know 100%, 100.000%, but he could take all the information that he had, including all the stuff by, what was it? Was it Aristotle or was it Socrates? Who had those 5 reasons why he knew the Earth was a globe.
Yeah, but the problem is, though, it violates your own first rule because you need to know, not assume or believe or deduce. You need to know before Eratosthenes can do his own experiment. So by your own rule, which, let's be honest, it's arbitrary, right? But
No,
I
it's
actually
not.
agree with it. It is arbitrary. It is arbitrary. You've decided that.
No,
But I agree with you on that. You do have to know. This is because ultimately, if Socrates or Eratosthenes or anybody else knew that the Earth was flat and applied Euclidean geometry and Cartesian coordinates, he's going to get a different answer, a very different answer, isn't he? So you need to know why they're important. You need to know what the shape is to know what maths to apply, right? What trig?
Right.
But Eratosthenes violated your own rule, didn't he?
No,
he
he
didn't know. He
He-
assumed.
He didn't. So the thing is,
he did.
I don't
He did.
think- I don't
Why
think
did
there
he
could
not?
be- I don't think there could be anything gained from arguing about what somebody who's been dead for 2,200 years knew and when he knew it and how he knew it. Okay. I
Yeah,
don't
there
think
is.
there's
There's
anything
a
to be
lot.
gained.
No. I don't agree. There's a lot to be gained because the problem is, Charles, kids are taught this shit in school.
I
Now,
never learned
whether
about
they-
Eratosthenes.
It doesn't matter. A lot of kids are taught it in school. Look, I've got an article here, right? This is a high school article. Let me
Right.
show you this here. This is high schools in Greece. They did a load of schools all together. All
Sure.
the kids in about 15 different schools. They all went out in the middle of summer on the equinox or whatever it
Right.
was. You'd have to read through it.
Right.
But this is from the World Journal of Education, right?
Right.
And it was supposed to be a modern day version of the Eratosthenes thing, right?
Yes.
So let's, in the conclusion at the end, it says, and I'll read what it says for your audience. They may not be able to read it. It says, inquiry-based hands-on experiments in classrooms require simple constructs to satisfy a student's curiosity. The ancient Eratosthenes provides an excellent inquiry-based hands-on approach for today's students to conceptualize and solve an abstract problem, not a real-world problem, an abstract problem that even contradicts everyday conceptions. And look at this bit. We all know that the Earth is round, although it appears flat.
Right.
So how do we know that? And why are kids being told that we all know that the Earth's round when I'm 41 and I don't know that the Earth's round and I've not seen enough evidence based in current science to satisfy myself that the Earth is spherical in shape? It appears, as it says in here, to be flat.
Yes.
But
it
how
does
do
appear.
how do we know that it's round? Because this article tells kids that we know it's round. Yet how do we know? Because Eratosthenes clearly didn't know. And if you pass the book to somebody else, fine. But we're all taught in schools. The kids are taught that Eratosthenes knew. Oh, sorry, he assumed. They're taught that he assumed. So in what logic is that sound logic? There is no logic for that being sound, is there, Charles?
Well,
It's called begging the question.
you're placing too much value on a pioneer, and that's
I'm not.
You
You brought him up. You brought him up in Nathan's.
that's because he said.
And the point is,
I
listen,
said the
Charles.
Eratosthenes method. He said how?
Charles,
How do you
Charles.
know the circumference? You can use the Eratosthenes method, but you have to
I'm
know
not
the Earth is
bringing
a
up-
sphere before you use the Eratosthenes method.
I'm not placing any weight on this guy at all. I don't even believe this guy. If he did exist in real
okay.
world and he's not a mythical creature like Moses or Noah, because you think Moses and Noah are mythical creatures, right? Didn't exist.
I never
If
said that.
Eratosthenes, no, but most people in your model do believe that. You blurfs do think that the Bible people, be it Noah and his ark,
I'm a Bible
you will-
person.
Okay, but do you accept that Noah did exist? Yes or no?
Yeah, he could have been mythical, Noah.
Okay,
But
okay, so he
but
could have been
Moses,
mythical.
I think I'm pretty sure Moses.
But
But anyway,
I'm
so
not. I'm
throw
no.
Eratosthenes
Stop,
under the
no.
bus. Call him a myth.
No. Stop. The importance to it is the opposite. It's adverse, not important to me. It's the antithesis of importance. It's totally discredited because I'm not even sure he even existed, right? But if he did exist, did he actually do this? Because here's why it's a problem. Eratosthenes was he was a mathematician, correct?
My understanding is he was the librarian, but he was probably well read
He was a
in
mathematician.
all these fields.
He was a mathematician.
Philosopher,
I don't think, yeah, philosopher. He was a mathematician as well. I don't think that Eratosthenes. Just so that I've got this right, and I want to double check to make sure that my thing is right. Eratosthenes. I believe that he was a mathematician. Yes, he was a librarian, but or the head of the library. But I want to get him up on.
But I think you're missing the point, because what we're talking about is we're arguing over what a pioneer may or may not have done. But science has moved on since this pioneer. Yeah,
but the problem is, when you said I'm putting too much weight on Eratosthenes, the reason why I put weight on it is to illustrate, one, the illogical nature of it, because he is begging the question. Two, that he's a mathematician. I don't believe that any professional mathematician would beg the question fallaciously and then base a whole world view on it, unless it was done after his death and they needed to pin it on somebody. Because I don't believe a mathematician would do that.
He's only begging the question if his point by doing that shadow experiment was to say, I don't know what shape the Earth is. It could be flat. It could be a sphere. I'm going to do this test. Oh, look, it's a sphere. That is a begging the question fallacy. You are 100% correct, which is why I argue that he already knew it was a sphere, and there's a bunch of reasons why he would have known it was a sphere.
We know that he didn't know. We know that he assumed.
Again,
or at least we're told that in school.
We're arguing over what his thoughts were. He's 2,200 years dead.
No, I'm not. The point I'm making, Charles, is not about his thoughts. The point I'm making is that the kids are taught this bullshit as though it's true, because this is what they call education in schools. And
I never learned Eratosthenes in school, and then you pulled up that thing, and it said, there's 15 schools in Greece. Well, what if you weren't in one of those 15 schools in Greece? Then you might not have experienced that experiment, and you might not have heard of Eratosthenes.
Yeah, but listen, Charles.
It's not like he's on the cover of the textbook. He's just a pioneer. Charles. He's the first guy to estimate the circumference of the Earth. That's it. End of story.
He was the first guy to calculate the circumference of the Earth.
Estimate. I said estimate,
Yeah, calculate is the word. Not
maths.
Estimate, calculate. But the thing is, Charles, the reason why it's important is because people like cats, conspiracy cats, teach children this kind of nonsense in school. Right now, flat Earth, whether you like it or hate it, is a topic that kids are bringing up in academia. They're asking these questions. Why does it even exist if it's so stupid? And then you've got conspiracy cats and all the physics teachers telling them things like Eratosthenes. But what they don't tell them is that Eratosthenes assumed that the Earth was a sphere. They teach them that Eratosthenes proved that it was because they use maths. Now, children then come up.
I don't believe
it is. It is.
I've asked you for a citation, and you haven't come up with any place that said that he proved the Earth was a sphere. He did not know the Earth was a sphere going in. He did his experiment. He proved that it was a sphere going out. I've never seen that citation.
Which citation? The citation that proves what?
That says that the shape of the Earth was unknown to Eratosthenes. He does this experiment, therefore he proved it was a sphere. I've never seen that, and
Charles,
that's
I've
absurd.
Got about 15 on screen where they all acknowledge that it was an assumption.
Okay, but he's not proving it's a sphere by his shadow experiment.
He's begging the question. He's saying, I assume that the Earth's a sphere, so I'm going to use all my spherical geometrics or my spherical trigonometry to calculate the circumference. But if he doesn't assume that the Earth's a sphere, he then doesn't use spherical trigonometry. He uses normal trigonometry, and then he doesn't make the deduction that we're on a sphere.
Okay, so there is one thing, a problem with your thinking is that he's not using spherical trigonometry. You just slice the spherical Earth. You just slice it in half, and you have a circle. So you could just use regular Cartesian coordinates, regular trig.
Until you use R.
That's just fine. Okay.
Until you use R.
Oh, okay. That's another topic. But the point that I want to make.
That's why it's a housekeeping question, Charles.
Oh my goodness. But you guys are skipping step one. You guys are
skipping.
We're not. Yes, you are.
We've addressed step one, Charles. He doesn't know that the Earth's a ball. He believes it or he assumes it. He applies the maths based on that. So he doesn't know. He violates your own rule one, Charles.
Okay. We've gone over this 100 times. But the whole point of my channel is that anybody can measure do these careful observations and then measure the shape of the Earth, not measure the size of the Earth.
How? You can't. That's not true.
It's right.
That's
It's
not
right there
true.
on the screen. There's.
It's not just
six-
because it's
there's
on the
six-
screen.
There's six
Just
explorations.
because it's on
anyone
the
can
screen,
do.
Charles, doesn't mean it's true. You don't have right. So when you're taking careful observations of the sun, we've been through it. We've discussed how you don't have any angles because you're using Euclidean straight lines in a Euclidean geometry with
That's your
Cartesian
point.
coordinate
That's your
systems.
argument. I don't.
Yeah, but
your
you're
argument
using the
doesn't make
wrong
any sense.
geometry.
Your argument doesn't make any sense.
No, just because you don't understand it doesn't mean it doesn't make sense. You're using the wrong geometry to obtain angles. And how do you get an angle when you've got a curved surface? That's one of the key questions that Nathan asks.
Well,
how do you get an angle?
I was measuring an angle off of a 2D photo, so you had a problem with that.
But you still got a curved surface, though, haven't you? How do you get
it was a 2D photo. So.
Yeah, how do you get? Yeah, so you're still using Euclidean geometry with curvilinear with thingy coordinates, and you're using the wrong tool for the wrong geometry to get the wrong results. So you can't do the shape of the Earth.
So do you have any positive claim? Because it seems that you've spent this entire 90 minutes responding to the stuff that I've got, but there's got to be a reason why you believe the Earth is flat. So do you have any positive claims?
Well, we're only talking about the sun, so let's keep it to the sun. I don't know what the sun is. I look up at the sun and the moon, and I just go, do you know what? I used to think that they were rocket landing pads. Maybe not the sun. But I used to look at the two main astronomical objects in the sky, and I used to think
the moon, right?
Whatever they are, they're massive
astronomical landing pad, yes, or a rocket landing pad, yes.
But since this topic, Charles, I go out all the time, and I'm looking up into the night sky, and I see an awful lot of shit moving, and a lot of stuff that's not got flashing lights. They've got solid lights, and they're moving. Okay, it could be Starlink, but there's only one of them. You could come up with a load of explanations for what they are.
There's only one Starlink. ISS. There's only one ISS, right?
No, yeah. What
but
I'm saying is,
Starlink,
I look up
like
and I see these
almost 1,000.
I see these things moving all the time, and I'm thinking, yeah, it must be a plane, but it's not flashing. It's not even yellow. It's white. What is that light? And I'm taking the dog for a walk, and the missus would be like, "Come on, you idiot! Stop looking at that light. It's just a plane." And I'm looking at it and thinking, "That's not a fucking plane. It's going too fast. It's not white. It's not yellow. It's not flashing." The point is, it doesn't matter what I think it is, but I'm looking up at the sky a lot more than what I ever did. So when you ask me things like, why do you think that the Earth's flat? I'll say, well, we're talking about the sun, right? And I look up at the sun, and all I can see is a metaphysical object that is more, in my opinion, it is more likely to be a signature from God himself saying, science the shit out of this, gentlemen, because physics doesn't even agree with what the sun is. You've got Professor Pierre Robitaille that argues that the outside of the sun is a solid object because it comes back with a particular frequency. Yeah, Dr. Pierre Robitaille, he argues that the sun has got a solid surface on the outside, yet current science doesn't say that. So he says that he's going against the grain. But the point of it is that if Robitaille is saying that the outside surface of the sun is solid, and the mainstream science is saying it's a fusion hydrogen, whatever, that doesn't convince me or persuade me that the sun is a physicality. I think that the sun might be it's just a light.
What about the moon?
To be metaphysical.
Do you think the moon is physical?
Do you know what? I actually look at the moon now and I wonder, are we looking back on ourselves? Is it a big, massive mirror and we're looking back on ourselves somehow? It's reflecting a different frequency of light. And because I look at it and I just think, like I look at Saturn and I see what I perceive to be an eye looking through a microscope. It's the microscope of God's eye, if you will, looking down on us. I look at the moon and I wonder, if that's really a rock, what's it made of? Moon rocks? Moon dust? What is the composition of them? And why is it that it's got weird attributes? Because like you can look at any high definition image of the moon, any high definition, and you can go into one corner and it'll be pin sharp, razor sharp, then go into the opposing corner and it's soft and it's got no definition to it whatsoever. Now, there are no photographs anywhere.
I think I know what you're talking about. Like if you're seeing the moon like with direct lighting, it looks kind of flat and soft. Is that kind of what you mean? Whereas you look on the side where the sun is hitting it, the craters at an angle, and you kind of see the shadow of the craters. Is that what you mean by
you get
soft
high
versus
definition?
Yes.
But there are no pictures anywhere in photography, and you should know this yourself if you're a photographer. If you take a distant photo, it's either all in focus or it's all out of focus because you've got your settings wrong.
Okay, but I think you're mistaking a direct lighting and I mean, you could do this with your carpet. You know, you look down at your carpet, and then you have a flash on your phone. Take a picture of your carpet, and then you take another phone, and then have a light from the side, and then turn your flash off, and then side lit carpet. You could see all the textures, and it looks like 3D. Whereas flat down, it just looks like a flat piece of carpet. So
but the definition
but
point
that
I'm making.
shows that the moon is spherical. That shows the curve of the moon, because
No,
you
it
have
doesn't.
direct
If
lighting
there
on
was-
this side, but then you have the lighting tailing off, and you can see the shadows and the craters on the other side.
You try it. You get any high definition image of the moon, high, 4K resolution, right? You can't tell which direction the light's looking at unless you can see some shadows. And when you look at the shadows, then you can deduce where you think the light's coming from.
Okay,
But when you don't
fair-
see the
fair
shadows, if you ignore the shadows so that you don't know the direction, and you look at the composition of the photograph, you can see that half of it's pin sharp, the other half soft and out of focus.
It's
Now,
not
you
out of
say-
focus. It's not out of focus.
It is though. It is. If you actually try it, bring one up, Charles.
Well, okay. So this is something where I'm going to encourage you to table that, and then possibly, make a short little video. Here's a response to Charles about the moon looking soft or whatever. Again, that's a claim I would
honest,
love
Charles,
to explore, but it is
should be the
not
other way
out of
around.
focus.
It should be the other way around, because I'm going to say the claim is that the moon cannot be in and out of focus on the same shot. But if you think that it's not out of focus, show me how it's not out of focus, because
my
one
goodness.
shot side of it is pin sharp,
that's
the other side of it is flat.
But I've never seen that image. With the images I've
They're
seen,
everywhere.
The
They're
images that
everywhere.
I've seen, and just to repeat myself, is that the moon, the craters on the moon are not like, huge mountains like the Himalayas. That they are surface, imperfections. But if you have direct lighting, if you're looking directly, like for example, the full moon, you really can't see craters on the full moon. If a high def 4K image, take a photo of the moon, you really can't see craters on the full moon. But as long as you're looking at a quarter moon, a crescent moon, a gibbous moon, that's when you see the terminator line, that's when all the details pop out. So,
I understand what
I'm
you're
not really
saying.
sure what you mean by out of focus, but
I think what you're doing is conflating out of focus with soft and low resolution. I'm not saying that the lit.
I'm
saying
interested
that
in
low
seeing
resolution.
I'm interested in what you're talking about. So please, find a not live, because we're now 96 minutes in. So we do have to wrap
any
this up.
high definition, any high definition picture of the moon, you can
I've
do
never
it on
seen
any
it.
video.
I've never seen it.
Well, maybe now I ask you, could you look at it for me and show me how it's
not during, because I normally try to have
Not
these
now.
things go run 1 hour, but we're now an hour and a half. Can we
Sure.
wrap this up, please?
Sure.
So I do want to thank you very, very much for this opportunity, and I do want to say the door is still open. I've had multiple episodes with several of my guests, and I really enjoyed talking with you, Anthony. So the door is open. I would love to, maybe if you want to tackle the stars, or if you want to tackle gravity, okay, then we can have future conversations. My door is open. I really appreciate it.
Can I just say, Charles?
Yeah, please.
The only reason why I joined I don't really talk to you people anymore, because there is no adult conversation. The only reason why I'm talking to you right now is because you are amiable, you are polite. So if you want conversations like this is how you need to be, ballers. Sean Hawkins, for example, you need to be polite. You can't be arsey. Because remember, we're the minority, and we're the ones that should be getting spoke to with some element of decency, but you guys don't do it. Charles does do it, and that's the only reason why Nathan's come to him, and sure, it's the only reason why I've come to him, and sure. So this is the way to be, guys. This is the standard. That's a compliment, by the way, Charles.
I sincerely appreciate that. Good people of the chat, I really, really appreciate it. I'm sorry I was not watching the chat. I told you that at the very beginning. I literally was not. I turned it off. I was not watching the chat because I wanted to focus 100% on my guest. I want to say a huge thank you to Sleeping Warrior, and I do hope we have future conversations. Thank you again, Anthony.
I've left you the link for the Metabunk thing. The stars in this side chat for you to consider.
Okay. I'll check that out, and I hope we'll have more of these.
Sure.
But for Charles Breeling and for Anthony Riley, thank you so much. Bye bye.
How?